Your test covers sections 7.1 to 7.3. So that means it covers circles, parabolas, hyperbolas, and ellipse. We're going to start looking at circles, and it tells us for the first two questions to write the standard form equation of the circle with the given information. For number 1, we have a center of -2, 4, and it contains the point 3, 12. So our equation of the radius, to find the radius, is going to be r squared is equal to x minus h squared plus y minus k squared. From here, you are going to plug in what you're given. So your center is that h and that k. Your point is the x and the y. So you're going to plug those in to find r squared. So it's going to give you r squared is equal, bless you, to 3 minus -2 squared plus 12 minus 4 squared. Your double negatives turn to positive, so that becomes 3 plus 2, which is 5 squared. And 12 minus 4 is 8 squared. So this is going to simplify to give you r squared is equal to 25 plus 64, which means r squared is 89. You're going to leave it as r squared because in your equation of a circle, which is x minus h squared plus y minus k squared, this is equal to r squared. So there's no point in taking the square root of r squared. You're leaving it as that 89. We said our center gives us h and k, so h is the -2, k is 4, and we found r squared to be 89. We're going to plug in these three values, and that'll give us x minus -2 squared plus y minus 4 squared is equal to 89. We simplify the double negatives, and that gives us x plus 2 squared plus y minus 4 squared is equal to 89. For number 2, we have a center of 0, 9, and it contains the point of 4, 5. So again, that center is h and k, and your point is x and y. We're going to plug all these values into r squared is equal to x minus h squared plus y minus k squared. So that'll give us r squared is equal to 4 minus 0 squared plus 5 minus 9 squared. This will simplify to give you r squared is equal to 4 squared plus -4 squared, which means r squared is 16 plus 16. So r squared is 32. Again, our formula for a circle is x minus h squared plus y minus k squared is equal to r squared. We said h is 0, k is 9, and r is 32. So we're going to plug these values in to give us x minus 0 squared plus y minus 9 squared is equal to 32. You can either leave it this way, or you can rewrite that as x squared plus y minus 9 squared is equal to 32. For number 3, it tells us to use the distance formula to find the equation of the parabola with the focus as 0, -3, and the directrix of y is equal to 3. Your distance formula is the square root of x minus x1 squared plus y minus y1 squared is equal to the square root of x minus x2 squared plus y minus y2 squared. Our focus is going to be x1, y1. Our directrix is y2. So we're going to plug all of those values in. We're going to have this as the square root of x minus 0 squared plus y minus negative 3 squared is equal to the square root of x minus x, because we don't have an x2, squared plus y minus 3 squared. Your x minus 0 squared is going to be x squared. The x minus negative 3 squared becomes x plus 3 squared. When we FOIL that out and simplify, it's going to give us y squared plus 6y plus 9. On the, or under the square root on the right side, your x minus x is 0 squared, so that cancels out. Then you have y minus 3 squared. FOIL that out, simplify. That's y squared minus 6y plus 9. Your square root is going to cancel out on both sides, so you're going to be left with simplifying x squared plus y squared plus 6y plus 9 is equal to y squared minus 6y plus 9. We're going to move all of our y terms to be on the same side, so that y squared on the left is going to subtract over. The 6y on the left is going to subtract over, and the 9 on the left is going to subtract over. Everything but the x squared cancels out on the left side. On the right side, you're going to be left with negative 12y. Because your directrix is y is equal to, we're going to solve this for y and divide over that negative 12 to give us y is equal to negative x squared over 12 for our answer. For number 4, it tells you to state the equation of the parabola with a vertex of 0, 0 and the directrix of 5. With this one, because your directrix is x is equal to, it tells us to use the formula x is equal to 1 over 4p times y squared. To find p, you're going to take the opposite of your directrix, so p is going to equal negative 5. We're just going to plug that in, so that'll give us x is equal to 1 over 4 times negative 5 times y squared. So that means your equation is x is equal to negative 1 over 20 times y squared. For number 5, we're writing the equation of the parabola with a focus of 0, 3 and a vertex of 0, 0. Your focus gives you p, so 3 is your p. That 3 is in the y place value, so we're going to use the formula y is equal to 1 over 4p times x squared for this question. We're going to plug in that 3 for p, and that's going to give us y is equal to 1 over 4 times 3 times x squared. So that'll just simplify to give us y is equal to 1 over 12 times x squared. For number 6, you're finding the constant sum of the ellipse with the focus 1 of 4, 0, f2 of negative 4, 0, and the point on the ellipse of 9, 0. So this f1 is giving you x1, y1, f2 gives you x2, y2, and your point gives you x3, y3. Your constant sum formula is d is equal to the square root of x1 minus x3 squared plus y1 minus y3 squared plus the square root of x2 minus x3 squared plus y2 minus y3 squared. So we plug these values in. That'll give us d is equal to the square root of 4 minus 9 squared plus 0 minus 0 squared plus the square root of negative 4 minus 9 squared plus 0 minus 0 squared. This will simplify to where your 0 minus 0 squared cancels out under both of those radicals. Underneath the first, That 4 minus 9 is negative 5. Underneath the second, the negative 4 minus 9 is negative 13. So this is going to simplify to give us d is equal to the square root of 25 plus the square root of 169. The square root of 25 is 5. The square root of 169 is 13. We add the 5 and the 13, and that gives us our constant sum of 18. For your next question, number 7, you're finding the constant sum with an ellipse of f1 of 0, 2, f2 of 0, negative 2, and the point on the ellipse of 0, 5. So your f1 is x1, y1, f2 is x2, y2, and your point is x3, y3. So again, our formula for your constant sum is going to be d is equal to the square root of x1 minus x3 squared plus y1 minus y3 squared plus the square root of x2 minus x3 squared plus y2 minus y3 squared. So we plug our values in. That'll give us the square root of 0 minus 0 squared plus negative 2 minus 5 squared plus the square root of 0 minus 0 squared plus negative 2 minus 5 squared. This will simplify to cancel out the 0 minus 0 squared under both radicals. And it'll be the square root of negative 7 squared plus the square root. No, sorry, this first one is positive. 2 minus 5 is negative 3 squared, and the second one is the negative 7 squared. So that'll give you the square root of 9 plus the square root of 49, which is just 3 plus 7, giving you your constant sum of 10. On your next question, number 8, it tells you to write the equation in standard form of the ellipse with a center of 0, 0, the vertex of negative 3, 0, and the co-vertex of 5. Remember, your vertex is A, your co-vertex is B, and you need both A and B in order to write the equation of the ellipse. Your A is in the x place, so that means we're going to use the formula x squared over A squared plus y squared over b squared is equal to 1. We said that x is negative 3, or sorry, A is negative 3, and b is 5. So we're going to plug these values in. It'll give us x squared over negative 3 squared plus y squared over 5 squared is equal to 1. We just simplify that, and it gives us x squared over 9 plus y squared over 25 is equal to 1. For your next question, number 9, you're writing the equation in standard form for the ellipse with a center of 0, 0, vertex of 0, 9, and co-vertex of 2, 0. So this one gives us our vertex and our co-vertex again. Again, your vertex is A, co-vertex gives you B. So that means your A is in your y place. So that's going to use y squared over A squared plus x squared over b squared is equal to 1. Your A is 9, B is 2. So we're going to plug those values in. It'll give us y squared over 9 squared plus x squared over 2 squared is equal to 1. This will simplify and leave us with y squared over 81 plus x squared over 4 is equal to 1. For number 10, we're writing the equation in standard form for the ellipse with a center of 0, 0, vertex of 0, 8, and focus of 0, 5. Your vertex is A, your focus is C. So we are missing B here, so we're going to use A squared minus B squared is equal to C squared in order to find B. We plug these values in. We're going to have 8 squared minus B squared is equal to 5 squared. That 8 squared is 64 minus B squared is equal to 25. We're going to subtract the 64 over. So we are going to have that B squared is equal to 39. So instead of finding what B is and saying that it's the square root of 39, I'm going to use B squared is equal to 39 and just plug that into our formula. Our vertex tells us what formula to use. Because that 8 is in the y place, we're going to use y squared over a squared plus x squared over b squared is equal to 1. We had a squared is 64 because 8 squared is 64. So we're going to plug that in. So it's going to give us y squared over 64 plus x squared over 39 is equal to 1. For number 11, you're writing the equation in standard form for the ellipse with a center of 0, 0, co-vertex of 0, 7, and focus of 0, 2. This one gives you your co-vertex, which is B, and your focus, which is C. So we have to find A. So we're going to use A squared minus B squared is equal to C squared. It's going to give us A squared minus 7 squared is equal to 2 squared. So that's A squared minus 49 is equal to 4. We add the 49 over, and we get that A squared is 53. We said B is 7, so B squared is going to be 49. That co-vertex has the opposite place value for the number that's not 0 that your vertex does. So because this 7 is in the y place for your co-vertex, that means that that A would be in the x for your vertex. So that means you're going to use x squared over A squared plus y squared over B squared is equal to 1. We said A squared is 53, B squared is 49. So that just gives us x squared over 53 plus y squared over 49 is equal to 1. For number 12, we're finding the constant difference of the hyperbola with the focus 1 of negative 2, 0, focus 2 of 2, 0, and the point on the hyperbola of 7, negative 2. Your f sub 1 gives you x1 and y1. F sub 2 gives you x2, y2, and then that point is x3 and y3. The formula for a constant difference is going to be d is equal to the absolute value of the square root of x1 minus x3 squared plus y1 minus y3 squared minus the square root of x2 minus x3 squared plus y2 minus y3 squared. So we're going to plug values in here. So it's going to give us the absolute value of the square root of negative 2 minus 7 squared plus 0 minus negative 2 squared minus the square root of 2 minus 7 squared plus 0 minus negative 2 squared. Next, we simplify underneath those square roots. So it's going to leave us with the absolute value of the square root of negative 9 squared plus 2 squared minus the square root of negative 5 squared plus 2 squared. We're going to simplify this some more. So this will give us this absolute value of the square root of 81 plus 4 minus the square root of 25 plus 4. Again, simplifying, we have the absolute value of the square root of 85 minus the square root of 29. This will be the square root of 85 and the square root of 29. The square root of 29 does not simplify. 85 is 5 and 17, which does not simplify. So you're going to leave your answer in this case just like this because your radicals do not simplify. When you take the square root of it, it would change the sign in between the two terms and give you both the positive and the negative of it, most likely, but we're not going to work with that. I just want you to leave it exactly like this. Your questions on your test will give you numbers that you're going to be able to take the square roots of, so that won't be the case for your test. For your next example, I'm going to change this. We're going to change the 12 in this order pair for your point to be 0, 4 instead of 12, 0. Okay. So with this question, it gives us a hyperbola with a focus 1 of 0, 8, focus 2 of 0, negative 8, and the point on the hyperbola of 0, 4. So again, we're going to find the constant difference here. You have an x1, y1 coming from f sub 1, an x2 and y2 coming from f sub 2, and an x3 and y3 coming from your point. Again, your constant difference formula is d is equal to the absolute value of the square root of x1 minus x3 squared plus y1 minus y3 squared minus the square root of x2 minus x3 squared plus y2 minus y3 squared. So we're going to plug those values in. It's going to give us the absolute value of the square root of 0 minus 0 squared plus 8 minus 4 squared minus the square root of 0 minus 0 squared plus negative 8 minus 4 squared. This will simplify to cancel out those zeros minus 0 squared under both radicals and leave you with the absolute value of the square root of 4 squared minus the square root of negative 12 squared. Underneath that first radical, that 4 squared is 16, so that gives you the absolute value of the square root of 16. Underneath the second, that's the negative 12 squared, which is 144, so that's minus the square root of 144. Your square root of 16 is 4. Your square root of 144 is 12. So that gives you d is equal to the absolute value of 4 minus 12, which is the absolute value of negative 8, leaving you with your constant difference of positive 8. The question on your test will be very similar to this one. So they will work out to where those radicals can be taken, and you're going to be left with a whole number for an answer. For your next question, number 14, you're writing an equation in standard form for the hyperbola with a center of 0, 0, vertex of 4, 0, and co-vertex of 0, 6. Your vertex is A, co-vertex is B. Your A is in the x place, so we're going to use x squared over a squared minus y squared over b squared is equal to 1. We said a is 4, so a squared is 16. B is 6, so b squared is 36. If we plug both of these values in, that's going to give us x squared over 16 minus y squared over 36 is equal to 1. Number 15 tells you to write the equation in standard form for the hyperbola with a center of 0, 0, vertex of 0, negative 3, and co-vertex of 7. Your negative 3 is A, your 7 is b. Because a is in the y place value, we're going to use y squared over a squared minus x squared over b squared is equal to 1. Your a squared is 9. Your b squared is 49. So we're going to plug those two values into this formula, and that'll give us y squared over 9 minus x squared over 49 is equal to 1. Your next question, number 16, tells you to write the equation in standard form for the hyperbola with a center of 0, 0, vertex of 9, 0, and focus of 0, 7. Your vertex is A, focus is C. So we're going to use a squared plus b squared is equal to c squared in order to find b. So that's going to give us 9 squared plus b squared is equal to 7 squared. This is then going to simplify to give you 81 plus b squared is equal to 49. We're going to subtract that 81 over. So we have 49 minus 81, which gives us negative 32. If you take the square root of this, it's going to give you b, but I don't care about b. I want to know b squared. So we're going to use the positive of this in order to plug in. A squared you can find as well. That'll give you 9 squared, which is 81. So we're going to plug this into our formula, that vertex, that a is an x, so it's going to give you x squared over a squared minus y squared over b squared is equal to 1. So we're going to have x squared over 81 minus y squared over 32 is equal to 1. For our last question, we're writing the equation in standard form for the hyperbola with a center of 0, 0, covertex of 8, 0, and focus of 0, 9. Your covertex is B, focus is C, so we're going to use, again, a squared plus b squared is equal to c squared to find a. That's going to simplify to give you a squared plus 8 squared is equal to 9 squared, which is a squared plus 64 is equal to 81. Subtract your 64 over. That gives you a squared is equal to 17. I don't care about a, I want a squared. Your b in your covertex is in the x place, so that means your a in your vertex is going to be in the y. So that means we're going to use y squared over a squared minus x squared over b squared is equal to 1. Your b squared is 8 squared, which is 64. So we're going to plug that and the 17 in for a and b, or a squared and b squared. So that'll give us y squared over 17 minus x squared over 64 is equal to 1.